Thanks for joining my 10-part video series, Debunking Flat Earth. Welcome to episode number 4. We're going to use the face of the moon, what we see with our own eyes, to disprove flat Earth. Now, when we're standing on our spherical Earth, whether the moon is on the eastern horizon, directly overhead, or the western horizon, as it passes by each day, we see one face of the moon. We never see the backside of the moon. We always see one side of the moon. You can't argue that because you see it with your own eyes. So the way that looks from this angle here is the face of the moon is tidally locked with the gravitational pull of Earth. So both of them are pulling towards each other. It pulls that face towards us as it goes around the Earth in 1 month, a little less than a month, 27 or so days to go around the Earth one time. The same side of the moon faces Earth all the time. We can't argue that. It's fact. That's just the way it is. On a flat Earth, as the moon circles over the flat Earth, like the models that we've seen, the sun and the moon go around in circles over the flat Earth, if the moon did that, when it passed by, we would see different parts of the ball. You can't argue that. That's just fact. That's what we would see. So in the position of the moon directly over the United States, the West Coast would see the moon like this. The East Coast would see the moon like this as it passed by because we're seeing different parts of the ball. You can't argue that. That's just the way it is with a sphere. You can't be looking at different sides from different angles as it passes by. So there's no flat Earth model with the moon as a sphere going over the Earth that you can prove exactly what we see with seeing only one side all the time, all over the Earth. You can't make a model, a flat Earth model that proves that. So watch this short video to see exactly what I'm talking about. The little ball on the ceiling right there is like the moon passing by Earth on a flat Earth. So let's watch how we can see different sides of the ball just by changing our position as the ball travels overhead. Okay, I hung this plastic ball on my ceiling to show you exactly what the moon would look like from a flat Earth. But on a globe, we know that we see one side of the moon all the time. No matter where you are on a globe, this is the side that we see, this red side here. But on a flat Earth, let's just say that I'm standing on the east coast of the United States, and then I move around to the west coast of the United States, looking at the moon on a flat Earth model, I see the backside of the moon. I don't see the moon rotate. I don't see the face change. I see the backside of the moon from the west coast. So if I move back around to the east coast of the United States, I now see the face of the moon that we always see. There's no flat Earth model that explains what we actually see. But some flat earthers will say, no, the moon is not a ball. It's not even a physical object. It's just a plasma up in the sky. It's a disk. So the problem with that, if the moon were disc-shaped on a flat Earth, it would become smaller and flatter as it traveled to the horizon. So when we look up on a full moon, do we see it looking like this graphic here, with it overhead a little further, and the furthest away? If it were a disk, that's what it would look like. If the moon were frisbee shaped, when it went overhead and traveled by like a train going over your head to a different location and so far away you can't see it anymore, this is what it would look like. But guess what? With our own eyes, we can prove that the moon is not a disk. It does not look like this when it goes overhead. So here's a cool thought about the face of our moon also, which we can see with our own eyes. If you're in the southern hemisphere, like Argentina, and you're looking east from Earth at a full moon, the moon is going to be rotated like this, what we see here in this graphic. If I'm standing on the equator and I'm looking east, the moon's going to look like that graphic there. If I'm in the northern hemisphere, most of the people in the United States, Europe, just the common places in the northern hemisphere, this is the way the moon appears in the sky to us because we're looking at it from different angles as it goes around our globe. Watch this little video that I did proving exactly what I'm talking about. And it shows you the view of the moon from the southern hemisphere, the equator, and the northern hemisphere. It shows you exactly why we see the same face of the moon, but rotated slightly. This video explains it perfectly. Watch. To show you that, I'm going to take my camera and show you the moon from this angle and then slide around to this angle. And you'll see what happens to the moon as it rolls when I go from here, the northern hemisphere, and here, the southern hemisphere. Watch this. Okay, this is viewing the moon from the northern hemisphere. And watch, when I roll around to the southern hemisphere, this is what it looks like to people in the southern hemisphere looking up at the moon. The markings clearly rotate around. That's impossible on a flat Earth. So there you have it. Just using what we see with our own eyes looking at the moon, you can prove that we are on a sphere and not a flat Earth. There's no flat Earth model that can explain how we see the moon. Game over for flat Earthers using the face of the moon.